Here we have another question outside the realm of the normal questions that will be asked in 1229, but this is still an interesting question for our understanding of the material. Find a pair of vectors, u and v, which are non-zero, orthogonal, and both orthogonal to w. W here is 4, 1, negative 2. So we've mostly been using the cross product to give us one vector that's orthogonal to two other vectors. But here we're only given one vector w. So what can we do with it? Well, if we imagine our vector w, we might find through other means another vector u orthogonal to it, and then use our cross product to find a vector v orthogonal to the both of them. Then we would see that both u and v would be orthogonal, and they are both orthogonal to w, which is what's required. But this, of course, requires us to work out a vector that is orthogonal to w, 4, 1, negative 2. And here we don't have a set operation that we can use. Cross product requires two vectors. So what we're going to have to do is just sort of almost guess and check, but we'll be a little more informed than that, and find a way to make a vector u that works. And of course, your approach can be different. What I'm going to do is I'm going to make the first component 0, so that I don't have to worry about it. I'll make the next component 2 and the next component 1. And the reason I'm doing this, I need u and w to be orthogonal. And if we check the dot product, 0 times 4, I chose the 0 so that we cancel out the 4, and then 2 and 1, and 1 and negative 2, those should cancel each other out. Okay? It's almost like we chose to make some of the components 0, and then performed the switch and change a sign trick that we know works in 2 dimensions. But then this vector has a dot product with w that's 0, so u and w are orthogonal. This isn't the only u that will work. This is just an example of how you might go about creating such a u. That's what makes it a bit of a challenge question. It's not a prescribed do this, then do this, then do this, get your answer sort of question. We have to think about it for a moment. But now that I've got u and w orthogonal, we can create vector v orthogonal to both of them by taking the cross product. Okay, so we know how to take cross products. So the first component of v, negative 4 minus 1. Next component should be 4 minus 0. And our last component should be 0 minus 8. So this gives us a v being negative 5, 4, negative 8. So if I take that v and this u, they are orthogonal to each other because the cross product is perpendicular or orthogonal to the two inputs. So v is perpendicular to u and w. And we designed u so that it would be orthogonal to w. And we can see both u and v are non-zero, and this satisfies all the conditions that we were asked for.